Hello everyone, Harsh Verma this side, and welcome to a new video in which we are continuing our networking revision using the book Network Warrior. So, those who have not been following these series, actually, we are going through this book called Network Warrior, which is by Gary Donohoe. Sorry for mispronouncing his name. Actually, this book is about the everything that was not covered on the CCNA examination. This book does not go very in detail about the topics, but it does outline and figure something that was not studied in CCNA, and sometimes outlines the topic very well. So it's a great asset for revision. And actually, what I have done is to create a few notes on my smartphone, which is here. And what I'm gonna do is to SSH into it and study the created notes. So we have been doing this for the past 3 or 4 videos and we are continuing the same. So let me zoom it into the terminal so you can also see. So we have studied what a network is, what the VLAN concept is, what a inter-switch link is, how VLAN propagation works, etc. Okay. And now topic for the day, we have also studied about STP, but topic for the day is quite small. It is just a little bit of introduction towards the layer 3 and what kind of databases switch or router or a networking devices maintains, particularly one with concern with layer 3. Okay, so starting with the first line reading, gateway. What a gateway is? Gateway was a device. Gateway used to be a separate device that translates one protocol to other. Yeah, we were talking about in terms of when we used coaxial cable for connectivity, into digital to analog mediums and vice versa. So modem you can say is a form of gateway. For example, if you had a device that convert a serial link into a parallel link, that device would be called a gateway. But in the modern context, gateway is the IP address or gateway is the addressing of the device that will handle the routing for ourselves. For example, currently my laptop is connected using Wi-Fi hotspot to my phone. So gateway for my laptop. So gateway should be perspectival or contextual. For example, for my laptop, the gateway is my smartphone. So every traffic that originates on this laptop will automatically gets handled by the smartphone because it shares it with a smartphone, and the gateway for my smartphone will be the ISP router, the IP that is provided by the ISP router, the gateway. Okay. Now, we have going introduced with the term routing table. So routing table in generic term is called RIB, or we can say in literally or in technical terms it is called RIB, which stands for routing information base, while the other protocols maintain their own databases. So let me go through it, then I will explain these in much more detail. So we have routing protocols like EIGRP, BGP, OSPF, and RIP. Actually, there are different kind or categories of protocol which we'll be going to learn in future. I guess I have studied this in very brief. Let me check it one. Okay, so we have not studied about the routing protocol yet, but we will be going to study in future video. Actually, the networking is topic which is mix and match of multiple things, multiple layer at once, because we have to understand the things as a whole. So you or we need to follow the topic on a consistent basis in order to get a hold of this. Okay, so where we were, one second. Yes, actually, we have to learn about the protocol types in upcoming video. So most probably we will see it in upcoming video, or maybe one or video later on this series. Okay, so we were studying that EIGRP has topology table. It's just a name given to a table that is maintained by the protocol EIGRP. Second, OSPF has the OSPF database. Again, OSPF database is also a name given to a table that is maintained by the OSPF protocol. Next, BGP's equivalent of topology or database is adjacency RIB, which stands for routing information base. It's not the generic RIB that we have just studied that a router also maintains. Okay. And finally, LOCRIB, which stands for local routing information base. So BGP maintains two variants of the table. while the EIGRP and OSPF maintains one version of table, which is called OSPF database and topology table. Uh, Reverse regrettably. Okay, so for a router running routing protocols has minimum of three database present. Okay, now we are studying about the hierarchy of the databases. Okay, so the first is routing information base. The routing information base that we have just this particular line, it is the control plane master routing database. In order to understand this, what is control plane? A control plane is a segmentation or a segment in a device that handles all the routing decisions. So a routing information base actually has all the learn routes. For example, if a single router is running multiple protocols, for example, we have seen how the distribution etc works, which means that we also put some route in static mode. We run multiple protocols in a single device. So we use VRFs, virtual route forwarding. So everything is segmented, but everything is consist in a single place. Not in case of VRFs, sorry for the slip of tongue. But if every route is contained within a single place with all its information, this is called routing information base. Okay. The second is forwarding information base. Forwarding information base is a simpler version because routing information base contains all the information. Going through that RIB will take a much longer time. So what we do is to simplify that. Basically, it's a simplified version of the routing information base in order to get quick resolution, because even a microsecond delay can cause a big impact on the network. So we try to avoid delay as much as possible. So it's a table. So what the data plane is, it's again a segment where the actual data transmission happens. Not only decision making, but the actual data transmission. So data transmission, lesser the latency, greater it is. And finally, we have protocol specific databases. We have OSPF, LSDB, EIGRP table, and BGP agency or local routing information base. Okay. And says that if the same route is learned from two sources within single routing protocol, then the one with the best metric will win. And what is metric and what is administrative distance? Actually, suppose we have a route to a particular network, okay, and the same route is advertised by two protocol. So in order to decide that the which route to be installed in the RIB, routing information base, actually the when route is advertised by two different protocols, they do get added in the databases. For example, learning the same route with OSPF will automatically enter it into OSPF database, while learning the same route using EIGRP also adds to the EIGRP local table. But from either these two, OSPF database and EIGRP table, which route will be installed in the final RIB, routing information base, is decided on the basis of administrative distance. So you can mark it as a trust factor. Lower the administrative distance, more trusted the route is. So we do have to understand and learn the OSP AD markings for the route. For example, directly connected route has a zero administrative distance. If it's a static route, then it's one, which signifies that it is way more trusted than any protocol, because the network administrator have himself configured this route. Okay, the same line, one with the best metric will win. Should the same route be learned with two routing protocol within a single router, the protocol with lowest administrative distance will win. So I have told you about the administrative distance first, which is a comparison between routes of two protocols with to finalize in the routing information base. But when we talk about the metric, for example, a route to a particular destination has actually two routes. For example, the same destination can be reached using two hops, and both the hops are advertised using the same protocol. So within the context of protocol, we have to decide which route to add in the routing information base. That is done using the metric. And metric is a kind of a protocol specific thing, because every protocol has their different metrics. For example, the EIGRP matrix is calculated on the basis of link speed, latency, bandwidth, etc., and may vary into thousands. while some protocols keeps the metric simple. For example, the RIP protocol just keeps their hops as a metric, so it ranges between 0 to 15, etc. Okay. The administrative distance is the value assigned to each routing protocol to allow the router to prioritize route and learn from multiple sources. So we have been through this. And finally, the last topic for the day is route types. What is it? So actually, we do have IP addresses, a range of IP addresses to that particular uh, device or particular IoT device. So we do categorize these form of IP addresses into the route types. First is host route. A host route is a 32-bit prefix length, which means a device, for example, this device is getting a single IP from a range of IPs. But if the range is limited to that a single IP, or for example, if it's a 30 range, it will be limited to two IPs, of which one is assigned to this link and other is assigned to that link. So if an IP determines it's a 32-bit prefix mark and it deterministic to a single device, then it's a host route. Then is subnet route. This subnet route is section of the network. For example, if we have learned about subnetting, actually I have not created any videos about subnetting yet. So if we go through this subnetting, we what we do is to divide and scatter the network for this particular according to the networking capacity requirement. So that's a section of network will be called a subnet route. For example, a subnet may contain 200 devices or 300 devices. It may not be the exact number because we used to keep the buffer IP addresses in that range. Okay. Finally, there's a summary. When we assign multiple subnets, for example 192.168, 1 dot something, 2 dot something, 3 dot something, so what we are doing is we usually commonly assign these one as a production network, two as a test network, three as a DMZ network. So when we combine all these subnets, what we call them is a group. Then there is major network. The major network is classful network with native subnet mask. For example, 192.168 has a major network of /16 because it covers all its subnet routes. For example, 1, 2, 3 will all be covered in /16. Then there is supernet. For example, if we are using 192.168, 192.169, 192.170, everything, then a super network will start to cover all these things. It may contain the mask lower than /16. And finally, the default route, which is the route to last resort. What is mean that whenever a traffic generates for an IP address that is not specified in routing information base, it will automatically be forwarded to that address in order to get a search for next hop. Okay. And to better understand it, what I did is to copy and pasted these chat GPT duck.ai. Okay. And it actually gives me examples. Okay, so for example, a host route has /32 prefix. A subnet route is, for example, as I told, 192.168.1.0, which covers the all IP addresses from 192.168.1.1 up to 192.168.1.254. Finally, there is a summary route, which is a route aggregation, which I already told you that 192.168.0.0/16 cover all the IP ranges that is in 192.168 X octet. For example, its third octet. Next is about classful network, which is a classful division of the network. For example, 192.168.0.0 is a part of /16. Okay. Next is super network, which is the aggregation. For example, I have told you that if there is multiple 192.168, 169, 170, these kind of networks, then their mask will be, for example, usually it happens to be 16, as is in the example it says that usually it happens to be 24, but when supernated it will be a lower value, for example /22. And finally, the route for the last resort, which is 0.0.0.0 with none of its bits set. For example, it spans all the IP addresses. And we do know that routers follow a principle of the highest prefix mix match. Sorry, not mix match. highest prefix match. For example, the larger the more route it will be preferred. So if nothing is found in the information base, the router used to forward the traffic to that default route. And that's it for this video. Thank you for joining in. Thank you.